We have a question here which involves essentially hidden quadratics, but they're much more hidden than normal. You can take the first equation and factorize in terms of root x, but it's guiding us along here. It's saying to do a substitution. It's going to help, I think, in the later part. So let's roll with it and do that. So if root x is y, then we can square both sides to give x is equal to y squared. And then it becomes y squared plus 3y minus a half is equal to 0. Y being greater or equal to 0 to make the square root work. So I could times through by 2 and try to factorize. It's not going to factorize. Or I could just go straight for the quadratic formula here, or I could complete the square. I think I'm going to go with quadratic formula. It's a bit awkward completing the square. So y is going to be minus 3 plus or minus 3 squared minus 4 times 1 times minus a half. Square rooted all over 2. Minus 3 plus or minus the square root of 9. And this is going to become plus 2 over 2. And that is going to be minus 3 plus or minus root 11 over 2. So remember, that is my root, root x. And so I can now work out x by just squaring in each case. x1 is going to be minus 3 plus root 11 over 2 all squared. I can actually take out the 2, it's going to be a quarter. And I'm going to get 9 plus 11 minus 6 lots of root 11. That's 20 over 4, so 5 minus 6 over 4, 3 over 2 root 11. If I have x, I should have actually, if I have minus 3, I should have already thought about this. Remember, y has to be greater or equal to 0, and minus 3 minus root 11 over 2 is less than 0, so reject. This is going to be our only solution. We haven't technically squared the equations, so we don't need to check if that one is spurious. That one will definitely be absolutely fine. Okay, let's carry on then. So part 2a, got x plus 10 square root of x plus 2 minus 22 equaling 0. And let's use a similar approach. You could actually get the square root on one side and everything else on the other side and then square it. I might do that in a minute, but let's look at doing a substitution. So I'm gonna, just like we did with the square, I let y equal the square root of x in the first one, let's let y equals the square root of x plus 2. So also we're going to need to have x is greater or equal to minus 2 for this to make sense. And y is going to have to be greater or equal to 0. And what happened? I need to substitute in. I need to replace this x. I need to square now. Y squared is actually going to be x plus 2. So x is going to be y squared minus 2. Therefore, y squared minus 2 plus 10 lots of y minus 22 is going to equal 0. Y squared plus 10y minus 24 is going to equal 0. Let's see if it factorizes. Actually, I think, oh no, we're gonna, minus 12, and wait, plus 12, and minus 2 will work. So y is equal to minus 12, which I can immediately reject, or 2. And then in the case that it's 2, remember we have the x is equal to y squared minus 2. So it's going to be 4 minus 2 is also going to be 2. Worth just like having a look at the equation. Is there going to be any problem? Or even substituting it back in to check. 2 plus 10 times root 4, which is 2, minus 22 does indeed equal 0. I'm just going to talk you through another way we could have done this question, because it doesn't say we have to do a substitution, but I think that is a good approach. Okay, so method 2, I could have written it as 10 root x plus 2 equals 22 minus x, and then squared both sides to give me 100 times x plus 2 equals, now I have to square this, 22 times 22. Well, that's actually 20 plus 2 times 20 plus 2. So 400 plus 80 plus 4, 484 plus x squared minus 44x. So x squared minus 144x plus 284 is equal to 0. Oh, this doesn't look very nice to factorize. I actually know that if we're going to get x minus 2 as a bracket from my previous solution, otherwise we have to try things out until it works. Of course, yeah, this is a non-calculated paper. Look, it doesn't take too long, I guess, because they're they're going to be fairly far apart to get minus 144x. So then we get minus 142 there, equaling 0. So x equals 2 or 142. We had at the start that x had to be greater or equal to minus 2, but that condition doesn't always mean you can just stop there actually, because there's actually, yeah, there was another condition. The right hand side has to be greater than 0 because the left hand side is necessarily greater than 0. So we also needed that x is less than or equal to 22, which means that we're going to reject this one and only take x equals 2. To be honest, it's just good to just kind of not, you don't actually even have to substitute fully back in. You can just see that when you put 142 in on the right hand side, you're going to get a negative, which is going to give immediate problems. So two different methods. In terms of complexity, somewhat similar, I'd say. Let's take a look at part B though. And actually, you wouldn't want to be doing the method 2 this time, because you'd end up with a quartic when you get this onto the right hand side and square it, get next to the 4 in there. And it doesn't look like it become a hidden quadratic either. So let's go with this substitution method. I think it's definitely going to be advantageous here. Let's let y equal, again, the whole of the square root. I do need this square root to be positive. It's probably best, there are going to be some conditions. Let's just see where we get before we worry about that. So y squared will be 2x squared minus 8x minus 3. And I can see if I have it, so half y squared is then going to be x squared minus 4x. Okay, that's good. Minus 3 over 2. So I can replace this by, therefore, a half y squared plus 3 over 2 plus y minus 9 equals 0. Suddenly that is a lot simpler. And at this point I can times 3 by 2. I mean, I could have times the whole equation by 2, but I didn't. Y squared plus 2y plus 3, actually I'm not going to rush it, plus 3 minus 18 is equal to 0. Y squared plus 2y minus 15 is equal to 0. And this again factorizes, so y minus plus 5, y minus 3 is equal to 0. So y is going to equal 3 or minus 5. Straight away reject that one. And then we can put it back in. So therefore 9 is going to equal 2x squared minus 8x minus 3. 2x squared minus 8x minus 12 is going to equal 0. Divide through by 2. Okay, this isn't going to factorize. 6 and 1 isn't going to work, and nor is 2 and 3, and we're out of options. So I think this time I'm going to complete the square because minus 4 is quite easy to deal with. Different approaches, they both would work. So that will give me x squared minus 4x. So x minus 2 squared is going to equal 10. Therefore, x minus 2 is going to be plus or minus the square root of 10. So x is equal to 2 plus or minus the square root of 10. Now, I think technically we should substitute that back in to check. I could be wrong. Are we guaranteed that it's going to work? Remember, we have the square root part. Remember, because we called that, all of that was y, we have that equal to 3. And then we could complete the square again on this. So x minus 2 squared minus 4 plus 3 minus 9 is going to equal 0. So here I'm going to get 10 regardless for whether I put in a negative or a positive. 10 minus 4 plus 3 minus 9. And that is going to be definitely equal to 0. So yeah, the negatives don't matter here because this is definitely going to be positive, and it's going to, when we're adding 3, we're going to be minusing 9, but it's all going to check out. So these two solutions are definitely valid. And yeah, that's a really nice question.